Hey, everybody, and welcome back to another episode of Ruby Rogues. This week on our panel, we have Valentino Stoll.
Hey now.
Luke Stutters.
Hey.
John Epperson.
Hello, everybody.
I'm Charles Max Wood from Top End Devs, and this week we have a special guest, and that is Máximo Mussini.
Hi there.
We've had you on before. I think we talked about Vite last time. Do you want to just remind us who you are, why you're famous, all that good stuff?
Last time I was on the show, we talked about Ruby, which is an integration I created for Rails and Ruby project to be able to leverage Vite as the bundler and dev server that will compile your assets. And it's an exciting week for Vite developers because the Vite 3 just came out yesterday. So lots of people are talking about it. And it's really great. It's faster and lighter than the previous version, while supporting more features and just being more standard JavaScript, which is great.
Yeah, I want to start the rumor that Vite Ruby is going to be the next asset pipeline for Rails, but we had DHH on and we talked through the other stuff that he's doing, so people would know we're lying. Anyway, you wrote some other packages that pull in some JavaScript and TypeScript stuff from Ruby. You got TypeScript and TypeScript types from serializers, and then you've also got JavaScript from routes and some of the stuff going on there. And you were explaining before the show, before we stopped you and said, let's just record this because it sounds more and more amazing the more you talk about it. What are we talking about here when we're talking about serializing and TypeScript, and how does that all go together so that it actually saves people effort and doesn't sound like a giant headache? Don't you wish that Rails came with a component library that would plug in the widgets, charts, graphs, and other things you need to build a solid user interface? And wouldn't it be even better if it looked great and was easy to integrate? Well, I have great news, folks. I found it. Avo provides all these things along with authentication, advanced search, menu editors, grid views, and a ton more. Plus, there's an open source version that gives a ton of stuff for free. Just go to avo.cool, that's avo.cool, to see what they offer and give it a try. I'm so excited to have an option that works out of the box, doing more than the basic CRUD operations, and I'm thrilled that I don't have to buy an admin theme and then convert their stuff to Rails views. This is built for Rails by a Rails developer, and it's awesome. Go check it out at avo.cool.
Exactly. Well, one of the advantages of using a bundler is that you are able to use things that are not JavaScript that couldn't run on a browser, right? Mm-hmm. For example, TypeScript, which is JavaScript with added types, which allows you to check for type safety. For example, let's say that if you're trying to do a string operation on a number, that's something the compiler can catch for you and prevent errors on production. So using Vite or any bundler like Webpack, for example, you can process that TypeScript code and ship normal JavaScript to production. But during your build step, the compiler can check all these errors for you. So a while ago, I worked on a library called JavaScript from routes, which is not a new idea. Mm-hmm. I just adapted it so that it works well with the native ESM modules. So previous approaches it's like back in the day, everything was global in JavaScript. So that's how you structure your code. I wanted something lighter that could take advantage of imports and exports. So I created this library, which from your Rails routes definitions, it will create helpers in JavaScript that can make requests to specific endpoints. Like, let's say a specific endpoint is your index action in, let's say, the contacts controller. So it's going to be /contacts, and it's going to be a GET request. All that information is available in your routes, right? So there's no need to code that manually. And also, it's a great place to make your own mistakes. And since you could write the path incorrectly or pick the wrong verb, this is not a post, this is a put, or this is a patch request. So my idea was, let's take all this information that is available and generate JavaScript or TypeScript from that, so that you can do anything with that, like make a request or just obtain the path, right? So it's like path helpers that you have in Rails, but for your front-end code in applications that are more JavaScript heavy, right? Not your typical server-side rendered app. So recently I've been using TypeScript more and more because I think it's a great tool to prevent mistakes, and you don't have to write that many tests, at least not for your front-end. I always like writing integration tests with a capybara and stuff like that. But I feel like the more granular tests, once you have TypeScript, most of them become unnecessary because it can handle so many of the typical errors like typos or type errors. So I begin to wonder, can we do something similar to the routes thing where I can just infer things from your backend code so that it becomes available in your frontend? So I like to use serializers to structure like your backend API, your JSON API. Some other people like to use JBuilder. One of the advantages of serializers is that they are very declarative. Everything that is going to be in the request, you know it load time, right? There's no compile time in Ruby, but you know which fields are going to be available in each serializer. Since the fields are usually declared like on using a DSL, like attributes. So you say, all right, this is the contact serializer, and the attributes I'm sending are first name and last name, right? So because of that, you have all this information, which Ruby's great introspection system allows you to take a look at, and we are able to generate TypeScript from that, right? So you have your contact serializer, and since you know it's going to have first and last name, just by looking at each serializer, you can already infer what the structure of the data is going to look like on the front end. You can even handle things like, let's say that you're using snake case in Ruby and you're using camel case in JavaScript, your conversion system can already handle that for you, which is great. And that way you just avoid all possible typos, like you use first name in snake case, but it was in camel case. Or even if you're not converting casing, it can handle mistakes like you were typing name, but it's first name and last name, not just name, or the other way around. Let's say that someone changed the backend serializer so that it only ships name, and you were using first name and last name. Now TypeScript can catch that, right? And one of the advantages is that since in Rails, everything is just driven so much by convention, you can have your backend model, let's say contact, which reads from the contacts table, which will have a contact serializer. So following, the tradition, if it's the contact serializer, you can also infer that, all right, the model is probably contact. So I'm going to look at the contacts table and I'm going to see which are the SQL column types. And from those types, you can also infer like the native JavaScript types. So let's say that I have a decimal in SQL, that becomes a number in JavaScript, or I could have a datetime field in SQL. I know that that's not going to be a date since JSON doesn't have dates, but I know it's a string that could be a date, right? So you can capture all this information from your SQL schema, meaning that your serializers pretty much stay the same way. And just to clarify, because now that we have active Java, there are also other types of serializers. I'm talking about the active model serializer stuff, right? Where you define which attributes are going to be sent. You can also define methods, like for virtual attributes that you want to send. And then you pass the model to the serializer, and the serializer will convert that to a hash or JSON of some sort, right? So the idea with types from serializers, the library, is you can automate the type generation process by leveraging that information in the serializers. And for example, if you have a virtual field, you can also specify the type manually. If it's the same name that you have on a column in your SQL schema, then it will infer the type from that. And of course, if the name doesn't match the convention, the DSL would still allow you to specify which type of model it is, or if you want to use a TypeScript interface that you have already defined in your front end. But it can just try to generate all that with the least amount of effort, right? Try to be smart so that you don't have to code things manually. And that's also a great way to prevent mistakes, because anything that you don't specify that is inferred will automatically change if the backend changes, which means that you are protected against these changes on the front end, because TypeScript will just fail once that code is regenerated. This was a long introduction, but so please ask any questions and we can break it down.
I want to jump in here because there was some foreshadowing about types here, so I'm going to jump in about the types. So this is a problem I had this week. I was writing a dashboard for configuring prices of a stimulus controller. And as you know, a price is a number. So it's a floating point number, okay? And I was kind of doing my page, and because JavaScript, it didn't come in as a number, it came in as a string, okay? And then I was kind of adding one thing to another thing, and things went horribly wrong. And what I had to do was I had to parse the float. Yes, I had to run the parse float. Yeah, I had to do parse float. And then everything started working. But before then, horrible things happened. And on top of that, I couldn't use a number type input field in the HTML, because if you use a number type input field, you can't get the cursor position, because I was doing some weird stuff that I couldn't restore the cursor position between kind of front end, back end updates. So it had to be a text field, which of course comes out as a string, right? When you read the value.
Right.
Yeah. Mm-hmm. Well, it does. So I had to do some parsing floats. But do you know what I didn't have to do during this, when I had this problem? There's one thing I didn't have to do, and I didn't have to learn TypeScript. All I had to do was parse the float and everything started working. So come on, can we not just kind of parse the floats and then, then we've got the types, right? So why bother learning the whole new TypeScript system when all we have to do is parse the float?
For example,
stop laughing, Valentino. It's a serious point.
Yeah, I just find it funny that Luke, his hatred toward typing in general, it's just hilarious.
I find it funny that he thinks that parse float's going to give him an accurate number. Oh, sorry.
Oh, come on. Listen, blame the IEEE, not me.
Wait, you guys use floats and don't pass everything around to strings and then use big decimal? I'm just kidding. Only when I deal with numbers. I literally do not. So on my very first project, okay, so this is a very fast story. Very first project, we were dealing with prices, and the people that wrote like this portion of the app left a few weeks after I arrived, right? And they had done everything for basically a checkout, basically this is like a thing that people that were selling stuff to people that were in a physical location, right? Like this was their checkout register, more or less, right? Like they had done everything using floats, and yeah, it was really bad. We ended up rewriting it. And so I learned a lot about the money gem. Like that, I mean, I contributed to that. That was like literally one of the first things that I ever did, and learned big decimal stuff. And it was great. And ever since, I'm just like, I just don't touch floats pretty much unless I don't care about the number at all.
Yeah, well,
that sounds like a real POS, and by POS I mean point of sale.
Yes, I had forgotten the term, but you're correct. It was a POS, and that was the problem. and look, at the end of the day, it's really easy to mess up your number. All you need is a 0.1. Like that's all it takes to have a bad number.
Well, and in JavaScript, I mean, integers themselves are messy. So floats, it's even more messy. So I'm just sitting here thinking,
if you use number, yeah.
So parse float, anyway, gross. So yeah, back to getting the types. I've done enough TypeScript to know that when you have your types well defined, right, you have your classes, it works really nicely because it validates everything, and it'll catch all kinds of stuff before you actually deploy, right? You compile and it says there's a chance here you're going to pass something that's not a number, right? And it's just expecting a number. And so you go in and you make sure that your whole chain of data is well put together. And there are a lot of other nice things that come out of TypeScript. And interestingly enough, all of the JavaScript tooling that comes in if you're using VS Code, uses a lot of the TypeScript tooling. So we benefited a ton from this, but I'm a little curious as you get into this. Are you using Vue? I'm assuming you're using Vue because we've talked about Vite, and that's kind of where that came from. Or are you using some other framework on the front end?
Yeah, me personally, I started this project by working on a Vue code base, a front-end code base with a Rails backend. But in practice, and I like to say the type system integration in Vue 3 is great. It's very easy to type your props using TypeScript types. In this case, TypeScript types generated from your backend. It's so easy to just pass that to Vue. And then your entire component and any children component will be strictly typed, which is great. But that same strategy will work for React, which has had TypeScript support for a long time. And same thing with Svelte, which also has really nice TypeScript support. So this approach works generally anywhere that you can have TypeScript, even in your stimulus controllers, if you were typing that code. I guess the only, as long as you have a complex structure that you're using serializer for, or even not that complex, but anything that you like to avoid breakage, you can already benefit, even if it's just a handful of serializers. I have a sample Rails application in the types from serializers repo, which is a Rails app, which has a Vue front end. And I'm using Inertia.js, which is a framework that connects your backend. It started in the PHP Laravel community, but it ties any front end, so React, Svelte, whatever, to your backend in a way that the backend decides which is the page. So you don't have routing as in Vue router or React router. Your backend, your plain Rails backend, which defines routes, is going to take command of, how the navigation is going to be performed. So the experience is the experience of a single page application, but it's as simple as defining a normal server-side render app. So it's like you sort of convert your typical Rails views are just components now. So it feels very natural because then your controller will return this data, in my case using serializers, and then your page, which is a Vue or React component, will take that data as props. So it's like you have a very, very explicit connection there, unlike Rails views where you can have instance variables coming out of nowhere. Here, you know exactly what's coming in from the backend into the front end. So that has a lot of advantages, and especially if you're using TypeScript, because then you can just type check everything and prevent mistakes.
Very cool. I'm a little curious because I guess I always want to see under the covers, right? So I understand it, it looks at the model, it looks at the serializer, it figures out what's going to get sent back, builds the TypeScript definition so that you can just import it into your application. I mean, that all makes sense to me. How does it actually make the sausage, right? I mean, what are you putting in the top of the grinder to fill this in, right? So in other words, when I run my build process with this particular tool, how is it, what APIs are you using and things like that? How much of this is JavaScript? How much of it is Ruby? And, how does it actually come up with the automatic type definition, if that makes sense?
Right. I used to develop mobile applications, and back in the day, it was very popular to use libraries such as Dagger, which would generate a lot of code for you, right? Dependency injection library. I always hated not to be able to see the generated code, and also hated the fact that code in some cases was very hard to read and it wasn't under source control. So if you upgraded the library, suddenly it stopped working and you didn't have a very good understanding of what changed in that generated code. So both for JS from routes and types from serializers, in both of these libraries, the approach I'm using for generating code is very explicit. I encourage you to have that generated code under version control. And also it's very concise code, right? I just took care that it looks like if you had written it manually, like very easy to read and like normal variable names, that sort of thing. So there are two ways that you can run it. There's like the simple way, like the advanced way, but it's also simple from a user perspective, which is you can run a rake task, which will just scan all serializers and generate interfaces for them. Or you can use a Railty, which is like a Rails plugin, which will get hooked up automatically if you have the gem installed. So whenever you make a change to your files in development, it will detect that and say, all right, you have modified this serializer. So next time you do a Rails reload, like next time you reload the page, Rails will automatically unload and load modified code. This is something that happens all the time, regardless of any plugins. In the latest versions of Rails, we have this great library called Sideberg, which works wonderfully, a lot better than the classic autoloader. So taking advantage of that process where Rails will refresh the code on every request if it has been modified, the approach that I decided to apply here is if I detect that some serializers have been added, removed, or modified, I'll keep a list of all these changes. And next time you visit the page and triggers the reload system, Rails will have like all this fresh code. Instead, it will just unload all code. And then what the library does is explicitly walk through the modified files, require them, which will load the fresh code, right? And then we have fresh information based on your current file to generate up-to-date interfaces for your serializer, right? This is slightly different than what I was doing in JS from routes, which I plan to update to this more granular approach. The advantage is that you're not doing any processing unless you're modifying things, right? And the other advantage is, as soon as you modify something and you reload the page, the generated interface will show up and it will be updated to whatever you're doing. And also we can do fancy stuff like detect that you have removed a serializer and then force regeneration completely, deleting all serializers and generating all of them, ensuring that you don't have dead code lying around. This is an approach that I would also like to apply to JS from routes, where I can detect if your routes file has changed or any nested routes files. I like to structure them under config routes and start splitting them. It will also be the same as if you use engines. And then we only run through the process if things have changed. So these are like the two ways to do it. One is just more optimal because it will try to avoid loading code that you don't need, just to keep the Rails reload process very smooth, especially for larger projects. Let's say that you have 5,000 serializers. We wouldn't want to load that code on every request unless it's needed. So that's mostly why we have this complex process of checking file changes and generating on demand. And then you have the normal process, which is a rake task, loads every serializer, generates all interfaces. And both are available depending on what you need. For example, I have hooked a Git pre-commit hook so that if you have modified any serializer, it forces the generation task, so that if you are not running your local server, your dev server, while making changes because you are just crazy, so you are modifying code without testing that, it would still regenerate the code accordingly. And then your build process, like in your CI, if you're running your build process, it will automatically fail if it doesn't match. Also, something unrelated to this that I wanted to mention. One of the great things about the new style of tooling like Beat is that it uses ESBuild to erase the types from your code, right? So one of the advantages is that you can try and use your application as if it was JavaScript, even if it doesn't type check, right? It's not like when you had your compiler in Webpack and if it didn't compile, you couldn't test it. Here, it's just like Ruby, it could be completely broken, but you can run it. It's just JavaScript after it goes through the process. So you get the benefits of types, but you're not slowed down by types, right? So it's like, and I think this is a direction that all compiled languages will strive to achieve in the future. It's like a new stage. It's like you have the benefits of types, but the fast iteration of an untyped language. So it's great because you could have, all right, the backend developer updated all the endpoints, and now the data that comes out is different, but you can still test and manually see which parts are breaking in the UI and incrementally fix that as you make changes and are in the live page, seeing how it behaves without having to fix all these type errors first and then be able to test it, right? So it just feels a lot more natural. It's just like working with Ruby, I would say.
So when you're building out these types, is it Ruby that's kind of writing out JavaScript or a TypeScript definition, and then you're using Vite to actually pull it into the project and compile it against the rest of the project? Or are you doing that?
Exactly. Yeah, that's the way. Ruby will generate a physical file, and after that, it's just a normal file in your project, and you will be importing that manually into your JavaScript application, which could be Vite or anything else, actually. Like Webpack, same thing. Or even anything that can process JavaScript and can process types, because you are importing TypeScript. So once it's generated, it's like if you wrote it manually, right? So same things apply to any manually written type. It's just plain code. But the advantage here is that you're not writing it and if you're not maintaining it. So you can't forget to update things. And also like accidental changes. Like let's say that you had two serializers that inherit each other, and you were not actively modifying like the subclass of that. You were just modifying the parent class, which is used in a certain page. So let's pretend that you have contacts and person serializer. You weren't modifying the contacts page. You wanted to modify the person serializer, which is used on the account page. So if you accidentally remove an attribute from the person serializer, then the contact serializer needs to be updated as well. And that on its own will get detected, right? Because that field will now be missing on the contact interface.
So when you say detected, at what stage in your development process does that happen?
Right. So
is that at the editor level?
The first stage would be the editor level. because if you're using Vite, you're not type checking on the dev server, right? But your editor is usually integrated with these tools. Even if you were not using TypeScript, like VS Code will try to infer types and things like that. But assuming that it is TypeScript, your editor the language server will be checking that. So that's like the first stage, which is immediate feedback if you have the file open, or no feedback at all if you didn't have the editor open, right? The second stage comes much later, which is typically your CI or your Git hooks, depending on what you do and how you configure that. But you're usually running the TypeScript compiler, or let's say that you have a Vue project, you're running Vue TSC, which will type check all your front-end code. So that's the stage where you would notice, oh, I forgot that this changed, and we haven't updated the front-end code. And finally, if it's some sort of somewhat a critical error, it could also make your build fail. But that's usually not the case unless you're doing something like, for example, Vue will use the types themselves to also generate JavaScript code. So from your Vue props, it will also generate code that can do runtime checks for those types. So in that case, that could cause, let's say that you're using server-side rendering or things like that, then it would complain, all right, you said this was a string, but it wasn't a string. It was undefined. So it can come up in different stages, but it's usually always earlier than shipping into production, which is what we want.
So that brings me to a follow-up question is, how are you testing these things? Or like if you say you have an integration test that you're testing from your backend database all the way through to the front end view, how are you testing that like pathway with this typing system in place?
Well, the story doesn't change much for how you write tests, because this only affects like type checking. So you're using this additional information to let the TypeScript compiler know what you're expecting to find there. But once you're writing integration tests, you're working with the compiled code, right? So there are no types there, but you do get a benefit, especially if you're using like prop runtime checks, like you would have on any development build in Vue, and also some React libraries can do the same thing, is that you have runtime checks on these props and the expected values that they should have, right? So depending on the configuration, it could also log some warnings while you're running your tests. And one good practice that I always recommend, first thing I configure extra when configuring Capybara, is fail the test if you have any warnings or error logs, because that's usually something that you want to avoid, right? So if your front-end code is doing warning or error logs, you at least want to know in the test, and in some cases whitelist it if that's expected in that particular test. But this is a great way to catch these errors very early. So let's say that the runtime checks in Vue are detecting a problem in how you're passing your props, but somehow it missed the TypeScript compiler. Unlikely if you're type checking. But then you would also get a warning. And if you are failing integration tests when you have warnings or errors, then you'll be able to also detect that in your CI.
So I'm here with JD from Raygun. JD, we've been talking quite a bit lately about Core Web Vitals and keeping track of the performance of your applications. And one of the hard things is that you kind of get this aggregated data from Google that changes over time, but it's got this lag on it. And I think we actually had some folks from Raygun where we were talking about, in particular, this problem and having some way of getting faster feedback on this kind of a thing.
Yeah, 100%. I mean, Google's official guidance is that you should be looking for a RUM tool and not relying on snapshotted data. So Raygun's RUM tool will collect all your Core Web Vitals, and last time I checked, I think we were at about 4 to 5 seconds lag on ingesting data. So pretty close to real time on how you're performing there. But yeah, we have first-class support in our real user monitoring product.
Yeah, real user monitoring means that each request that comes in, each track that people follow, that's what gets tracked, and so you know your numbers right away.
Yeah, that's right. Actual data from actual users, it's so much more valuable than synthetic data. And you also collect it across the entire user base. So you can see, like, who are my 1%, most disenfranchised users who experience the worst sort of performance. And between us, Chuck, I'm stoked that Google's doing this, because as a user of software, I want my software to go fast, and I'm really glad they're creating a business incentive for all of us to work on the performance of our software.
Yep, absolutely. So, folks, if you want a real user monitoring tool that'll keep you on top of your core web vitals, go check out raygun.com, and you can actually just sign up for a free trial.
Yeah, this is cool. I was checking out your generator specs, which are fantastic. That basically show, you have kind of like your typed interface files and type definitions that get generated that you give like plenty of examples for. And it's really cool how configurable like you've made the generator itself. So if there's a special type that your database has in it that, maybe it isn't covered necessarily under TypeScript one-to-one, right? Like a JSON column or something like that maybe just this doesn't pick up right away. You can define that pretty easily. I'm definitely going to start using this. This is cool.
Yeah.
This is the other thing I saw is that I've started using a lot more JSON-B in Postgres. And of course, fine, you've defined a type, but in my case, the inside of the JSON needs to be typed. So in that scenario, what you're saying, Valentino, is you can actually kind of define the internals as well.
Yeah, I'm seeing correct. You can customize even on a serializer level or attribute level. There's like configurations that you can set up for it. But Massimo, you can speak more to that.
Yeah, by default, it will try to find a related model to the serializer. So it's going to try to infer it by name. If it can't do that, then it doesn't have information. By default, I chose to make it like type safe, which is the unknown type, right? So if you have a field and you don't know what it is, it will say it's unknown. And what that forces you in TypeScript is that if you have a type that is unknown, you can't use it directly. You have to manually cast it to something else. So that prevents accidental usage. It's like you don't know what it is. So you should be careful. You should cast it to a string or cast it to a number or parse float. But the library also allows you to configure that so that if it's unknown, it becomes any. And I have an example on the generated tests. So then it's just you do what you want because it's any. So you have received this field. You don't know what it is. You can call any method. You can access any property, and TypeScript wouldn't complain. I don't recommend that, but in legacy projects, that might be a good way to start since you probably don't have types and everything would fail when you turn it on. So that's probably like a migration path. This is very new, actually. So it is configurable, but not that configurable. Like there are certain assumptions that I'm making here. Probably the most restrictive one, and it's something that people are going to probably get excited about the library and then realize, oh, but this doesn't work with active model serializers. It works with this weird unknown library that looks like that, but it's something else. Can I trust this? And so because I need full information to generate the types, right now the library is specific to another library I made called OJ serializers, which is like an active model serializer replacement that will just like active model serializers, it's going to keep track of which attributes each class should generate, which associations it should generate. So here, this library augments that to also include the types that you manually provide, if you provide any. It could potentially work with active model serializers. There's no reason why it wouldn't, other than I'm not using active model serializers. But like if you like this approach and for some reason don't want to use OJ serializers, like you have a legacy project, we could try supporting both libraries, since the only difference is like how these attributes and associations are stored internally and how to tell if it's like a has many association or has one association, that sort of thing. So it should be pretty small in terms of the whole generation flow. Basically, if you have the information, you should be able to generate the types. So how to introspect a serializer, that's the question. Like this could potentially work with, I don't know, some deprecated libraries like Fast API JSON serializers from Netflix. You could probably use the same approach since it also has all the information it needs at the class level, right? At load time, once the class loads, you already know which attributes are going to be sent, which associations it has. Like the only case where you wouldn't be able to apply this technique is any case where the content is completely dynamic and it's not introspectable at the class level. So for example, JBuilder, until that block runs, you don't know what's going to come out of it. There's no way to introspect that block at generation time. So like, let's say that I want to have a rake task that can infer types from my JBuilder calls. That's not possible because that code will be executed at runtime. So until it's executed, you have no way to know. You would have to run the code to be able to figure out. And also it doesn't have like a comfortable way to check attributes and has many associations and that sort of thing. For example, one of the advantages of serializers and this, declarative nature, the schema thing, is that when you are using an association, you can assume that it's going to use another serializer to serialize those items or item if it's a has one. So you can also import, what the library does right now is import the types from those serializers, which assumes are also going to be generated by the library. So as a result, all your associations are also typed. And this can go many levels deep. Like you could have your profile serializer, which has many contacts, and those contacts have many phones, serializers, and so on. Everything will be typed just using TypeScript and normal imports. Like you would typically write that code manually, right? In some cases, you might do the whole interface with nested objects, but typically you will have like smaller interfaces for each of the components.
So one of the things that I think is like super interesting about this, right, is I think obviously it specifically is working to solve a problem where Ruby and, JavaScript are getting married, right? So like it's solving a problem in the interface between them, right? And it's pretty elegant. And even if we iterate from here or whatever, like I feel like, how should I put this? Like I think you actually said it in your description to the library, right? You said it earlier on the podcast too. Like it's easy for the back end front end to become out of sync, right? Like we dry things up because we don't want to do things in two places. We do all this stuff. This is like kind of an extension of all that stuff. Like I think it just makes a lot of sense. Maybe people aren't using TypeScript right now and they're not going to get all the advantages or, things like that. But this is a super elegant way of basically handling that interface. So I think it's like super interesting just from, abstract sense, I guess, right?
Yeah. Something that I haven't tried, but I know it's possible, especially if you're using like mainstream editors like VS Code, is that you don't have to write TypeScript to benefit from the type system. So in some cases, you can use the JS doc style of comments where you add a comment to your JavaScript code saying this variable or parameter has this specific type. And it's more awkward because you also need to specify how to get to that type. But that's one way where you can start, even if you're not writing TypeScript, you can start benefiting from like these automated generated types without having to migrate your code base. I'm not really sure how robust it is. I know that like some framework authors, one that comes to mind is the author of Svelte, Rich Harris. He likes to write JS doc because he doesn't need to transpile the code afterwards. It's just JavaScript. And so the library and the generated types that are generated with TypeScript, that all works from inferring types from comments, where you manually specify which type it is using comments. It's very awkward. Like once you're familiar with TypeScript, it just feels a lot more natural. The JS doc thing feels like sorbet, where you have to write all this extra code just to provide the types. But it might be a great way to incrementally add a type checking to an existing code base. Also, I'd like to say, if there was something like TypeScript for Ruby, where you can gradually start providing type information inline in the code using like a sensible syntax, I would use it. But for now, like sorbet for me has too much typing overhead. And also like the readability of it is not ideal for me. So it's like that. This is why I'm experimenting with these approaches. It's like use the library that does have type checking written in a nice way and just test the hell out of the Ruby code, right? Because when you don't have a type system, you do need more tests. And I do have to say that that's one of the advantages of using TypeScript on the front end. It's like a lot of less bugs in your code. So less tests to write as well. And especially if you don't have to maintain the types, it's just like a great trade-off. It's like, I need to write less code and I get more safety. So that's great. Like less tests, no extra types, manually written, and you still have all this confidence as long as the backend is doing what it says it's doing, right? You can still provide the wrong types in your backend code. There's no solution for that until you also do like a Ruby type checking system integration. Like that would be the next step for something like this. I think would be to use the Ruby type system to generate these types automatically, right? Even for your plain methods. Like you have first name plus last name, Ruby knows that's a string because both arguments are a string. So, and the method is returning that. So the method returns a string. And then you would be able to automatically generate TypeScript for that because, Ruby knows it's a string, right? But right now, the typing story in Ruby it's like very early days, I would say. So it's still awkward to use those tools. They exist and people are actively working on them, which I think is great. But at least from an author perspective, like right now, it will be very cumbersome to try to leverage that.
Yeah, I will say the RBS typing stuff from Ruby is kind of as close, I think, as you can get. I agree with you. The method typing for it is not the greatest of syntax, comparably to something like TypeScript. But I think we're close, right? Like the new Ruby typing with RBS as opposed to like Sorbet gives you that kind of external typing definitions, right? Where it creates these extra files that define everything, which I think is better, like you say, because then you can either have it as an extra added, right? Or it'll still work without it, right? So it will be interesting to see how that integration goes. Because I would love, like you said, I would love to use this natively in Ruby instead of having to ad hoc something together. But I wanted to circle back on your serializers because I'm super curious why your OJ serializers don't just hook into the active model serialization API.
Right.
As
the active model,
it seems like
the active model serializers library has like an interesting story. Like the most popular version was 0.8, I think. Then there was like a failed 0.9, which got reverted in 0.10. And then the library like became, I wouldn't say unmaintained, but it's just not actively being developed. At least, and let me check because I don't want to say things that are not true. But I was using it in production in the 0.8 days. And yeah, it's no longer maintained. So that's why I decided to create my library, was that we were having performance issues related to active model serializers. We were serializing like 20,000 items, things like in that kind of number. And the memory usage just grew exponentially. And garbage collection started to perform worse and worse. The more items you would serialize, the worse it got, right? Same thing applies for, like, if you are loading lots of active record models in your application, you will have the same issues with memory pressure and garbage collection poses. So something that I wanted to experiment was, can I write a serializer library that has almost the same interface as the active model serializers? Because we had a large code base and I didn't want to spend a lot of time migrating it, but it doesn't have the memory usage problems. So what I came up was the design of it. You define everything in a very similar way, and you have instance methods like in active model serializers. Some other serializer libraries, like the Netflix one, fast JSON serializers, they deal with that by eliminating instance methods. You don't have instance methods, so we're not going to create like serializer instances. Forget about the instances, no memory, right? But it's more awkward to use. You have to define methods passing blocks. It's hard to navigate your Ruby code. Like, you can't go to method because it's no longer method. Like, that's that kind of small thing. It's no longer Ruby, right? You're using this DSL, which doesn't feel as natural, right? If I'm defining a name method, which is first plus last name, the most idiomatic way to write it is by defining a name method, right? Not defining an attribute name where you pass a block to it. The way I solved it is by having a cache, a thread local cache for serializer instances. So there's only one instance of each serializer at a given time, like 0 or 1. If you have used it, there's 1. If you haven't used it, there are 0, right? And then the same serializer is used to serialize all objects of that type in any nested association, right? Like, taking advantage of the fact that the normal request will run in a single thread, right? And if it runs in more threads, then it will just create more serializers, one per thread. But basically, the strategy is thread safe. And then if you're serializing 20,000 items, you could have a cursor from your database pulling 100 at a time, but you're not creating serializer instances. You're just reusing that instance for every object that you're serializing. And as a result, the performance improved a lot, because now we didn't have, we didn't use as much memory to serialize them. And we could also use like lazy strategies where you're pulling data and serializing. Of course, your string buffer grows unless you're using streaming, but it's not as big of a problem as like creating all these serializer instances everywhere. It's very niche, but I think since the result is so close to the original thing, like there are no downsides.
I'm going to jump in and talk about types in Ruby, which obviously I hate, but we did cover RBS and the type prof tool. Maximo, are you familiar with type prof?
Yeah.
Yeah, so the type prof tool kind of, I would suggest to you that the type prof tool kind of does what you were talking about, but suffers from a slight lack of documentation in English at the moment. But I must shout out the talk at RubyConf last year from Yusuke Endo, where he talks about using typeprof to automatically generate types on existing code.
I think this is a great approach, and probably the best approach that doesn't require modifying the Ruby grammar, right? The grammar of the language, which would be necessary if you wanted to do inline types. And that's like a huge project and probably not backwards compatible or just crazy complex. So I think this is where things are heading, right? Trying to reduce the developer effort to have these types, but to be able to statically analyze code, and in this case using like runtime combinations of inferring types and keeping track of types so that you can catch more mistakes without having to write tests manually.
I wanted to talk about your Vite full reload plugin.
Yeah.
I thought this was really cool. I mean, looking at the source, it looks like you're just sending a WebSocket message to Rails to tell it to full reload. Is that possible?
Not to Rails, but to the client
of the
Vite server, right? So when you set up your Vite
that's super cool.
You have a Vite client tag, which what you're doing is you're injecting in development only the plugin that Vite provides so that it can connect to the dev server and do hot reload. That's where you modify your code, and without reloading the page, it will automatically update a component, for example, without having to re-render the whole thing. So that's what we talked about last time, like being able to see your changes super fast without reloading the page. So this plugin is really simple, as you saw. All we are doing is leveraging the fact that Vite is already watching your files so that when we detect changes to certain files, we know that there's no way to hot reload this. And this is not even JavaScript code. So Vite wouldn't track it by default. So what my plugin does is it watches files like, let's say, your views, if you're using server-side views in Rails, or it could be, in this case, serializers. And all it does is sends a WebSocket message to the connected Vite clients saying something changed, so reload the page. And this is a mechanism that Vite already supports when you're making changes to things that don't have hot reload. So if Vite fails to find something that can be hot reloaded, by default, this is the behavior that it has. It will reload the page, which is sort of like the live reload some people are familiar with. Like Vite is a lot more granular.
I still use it. It's great.
Vite can be more granular than that, but the fallback mechanism is reloading the entire page. So in this case, it sends the message when any of these files are changed. And the way that I'm using it, and also it's funny because last week, the Laravel team from PHP, they started using this plugin in their official Vite integration as well for the same reasons, which is you modify a backend file and you want to have like the same instant response of, I want to see my updated code without having to manually reload. And in this case, since we're using generation tools that will trigger once the Rails reload process is triggered. So Rails, by default, is able to tell your code changed, but won't unload things until a new request comes in, right? So by default, Rails will wait until the next manual reload where you hit reload in your browser. That's when Rails will unload and reload your code, because you could still be making more changes. So it wouldn't make sense for Rails to unload every time you make a change. So it waits until you reload the page. So by adding this plugin, what we are forcing is an automatic reload, triggering the Rails reload process earlier, which gives you the illusion that once you modify your serializer, the process is running to generate like your TypeScript interface. But what is happening is actually a lot simpler, is that you modify that file. The Ruby side of things just says, all right, I know that this file was added, modified, or delete. I'll remember that. Then the Vite plugin messages the connected client saying, reload the page, something changed. When the new request hits the Rails server, Rails will unload the code using Sideberg, and it will run any unprepared hooks, which in this case will check if any serializers have been modified and generate code, or check if your routes have been modified and generate code, or anything that happens on reload, right? So it's just like the final piece in getting a super smooth experience working with Vite, because now your backend changes also feel like they are hot reloading, right? But in practice, it's very simple. It's just reloading for you.
Since we've got John on, I did want to talk about globbing all the stimulus controllers in. So it talks about on the page, it kind of does like just get all of your stimulus controllers and load them all in. So I've been doing a bunch of stimulus in the last 2 weeks, and I now have a fair few stimulus controllers. Okay. But what I'm doing is I'm just kind of loading them in on the pages that use those components. Do you just glob in all of your stimulus controllers onto all the pages?
Generally, yeah. So I don't know. I'm kind of trying to work towards a new pattern myself that I don't necessarily suggest to everyone, right? Where I am using like JavaScript's like class stuff, right? And some inheritance to try and basically abstract some stuff that's common to a lot of different stimulus controllers. I don't know that that's a pattern that's generalized for everyone. And that ends up creating like dependencies. It does get resolved. So globbing still works unless you're trying to load stuff outside of either the new import map stuff or a builder of some kind. So if you're on old sprockets, right, then it's an issue. But outside of that special use case, yeah, I glob everything and it works pretty good. The thing about stimulus, right, is it's listening for events in your browser, right? It's listening for things to be added or removed from the page. And so it doesn't activate on pages that it's not on. So having Rails or some other system, right, say, oh, I don't want stimulus to be loaded on this page, I think adds needless complication. That's just how I sit with it. But if it's working, I also am not going to kick you in the pants to make you quit it. Go ahead, Maximo.
I agree with John that since Rails, once you add stimulus, it's going to try to track any of the data controller properties, right? So it's already making the work anyway, right? It's already querying for that. So having more controllers or less controllers doesn't really have a lot of overhead, right? So the only difference is that the list that stimulus is going through is a bit bigger. So unless you have like huge code associated, let's say that you have a particular stimulus controller which is applying, I don't know, a what you see is what you get editor, which is only used in one page. So what you're trying to avoid is not the stimulus controller itself, but the dependency of this third-party library that you would like to import later, right? Or not import at all until it's used. So a combination that works really well is you still glob your stimulus controllers, but you do a dynamic import for the heavy library. And only when your stimulus controller is loaded, then you perform the import and you use that heavier dependency. That's a pattern that works really well if you want to get the benefits of a lighter bundle without having to, because if you are importing like a static import, then of course having all your stimulus controllers will make that bundle larger, but you can still use dynamic imports to split the less critical parts.
I do weird stuff. Okay, everyone knows this. I do weird stuff, and I keep all of my stimulus controllers in separate files. So every stimulus controller is a separate request on the client. So it massively increases the page load time when I request on my stimulus files. But I accept that this is not a normal thing to do. And I also, when I eat food, I don't like the food to touch either. So I like to keep everything in nice separate requests. But moving swiftly on from my strange structure, I wonder if it's worth talking about the concept of zero build. So one of the kind of overarching themes here is the idea that stuff happens for you. Okay, so you never have to kind of manually trigger a rebuild. It kind of all happens automatically, right? And I got really into the idea of zero build JS, and I started using libraries like Claustrophobic to completely avoid any kind of Webpack style jump. But this kind of thing makes me rethink the idea of zero build. And instead of saying this is a kind of zero build stack, it's a kind of zero manual build stack where everything just happens for you automatically. So we still have the same amount of kind of overhead when actively developing, as it just kind of takes care of it for you. But it is, transpiled. Have you ever played with the idea of a kind of zero build JavaScript stack where there are no transpilers? You're just using native browser features. And do you think this is where things are going, or will there always be this kind of tooling? So we will always have to have a system like Vite to maximize productivity.
Well, if we're talking about things like TypeScript, there's no way to get rid of a build process, right? There are proposals to bring TypeScript to the browsers, but I think that would just stall development, right? It could be very problematic. You're just increasing. I mean, the browser surface area is ever increasing, but would just be ridiculous, right? It's like those proposals to bring React to the browser so that you don't have to import it. That would just freeze React forever, right? Which doesn't make sense. You want libraries to evolve and to improve and to patch security issues. Like, there are so many reasons not to have that code in the browser. So I think to some extent, there are always going to be good reasons to transpile code and to use a build tooling, especially if it's something like Vite, where you have a nice development experience that is actually better than the zero transpiler thing. For example, if you compare import maps with Vite, when you're developing with Vite is just faster because you have hot reload, which you wouldn't have with import map, where you have to reload the entire page. So I think there are a set of trade-offs, and the import map thing comes in really handy for very niche cases, I would say. But in most cases, using a transpiler will just get better results without human intervention, right? It's very easy to misconfigure or like to have a large cascade of requests. Even if you're using ACP2, that doesn't mean that it will perform better than a smaller JavaScript file that combines all the things that you need. Also, like features like tree shaking, which are now even more popular than back in the day, thanks to the native module system. Now all tools like Rollup, which is what Vite uses, are able to detect things that are imported but not used, or not even imported, and that's going to get rid of all that code. So, for example, a nice example is Lodash, right? It's like you would say, oh, don't use Lodash in a no process tooling, right? But Lodash is still useful, and it's like utilities that have been developed over many years and are super robust and are great at what they do, right? And you don't have to write that code manually. So one of the advantages of tree shaking is that you can just import from Lodash ES, which is the ESM build, and any utilities that you're not using will be removed. So you will be using just the code that you're actively calling in your JavaScript, right? You could even forget some imports and leave them there, and your build tool will detect you're not calling that code, so I'm going to remove it. So let's say that you only wanted camel case from Lodash, and you don't want like the rest of the 500 methods. Those functions won't be included in the final build. So that kind of thing is very hard to replicate on zero build tools. And that's kind of why I think they will always be around. Perhaps not as popular as in the latest years, but I think they will always be good reasons to do that.
All right, we've been going.
Lodash is the jQuery for 2020s.
All right, we're in an hour and 10 minutes. Probably have to get to some picks. Máximo, if people are looking at this and they want to reach out to you about it, how do they find you?
You can find me on Twitter. My handle is @Máximo Mussini with double S, just like my name. And you can also find me on GitHub. It's El Máximo. And I think that's it. I'm also in Discord, in the Vite.js Discord, on the Rails and the Eels channels. I try to check it out like once a week. So that's another avenue. And also a place where sometimes I announce like new versions and things like that.
Cool. Hey folks, this is Charles Max Wood from Top End Devs. And lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com. All right, well, let's get some picks in and wrap this sucker up. John, do you have some picks for us?
I do. I have one serious pick and then one pretty fun pick or whatever. So I'll start with the serious pick first. So I just have been kicking around. I am not completely satisfied with a lot of like task management systems in general, and I feel like I discuss with other people, and other people seem to also have some dissatisfaction. So I'm on a journey to find something better. And one thing that I recently ran into, which is actually pretty cool, was Smartsheet. So it's like a task manager that also has like a Excel like spreadsheet kind of view as well, which is actually pretty cool. But the fact that like I can enter stuff in from cards, I can view it as a spreadsheet, and the fact that they have a built-in Gantt chart, which is like one of the most difficult things to make in my experience from task lists, is very nice. So I'm still exploring this thing. So I'm not giving it, the platinum seal of approval or anything. But so far, the experience has been pretty good. I've been using it for about a week with a client. And it seems to be very they seem to be able to pick it up pretty intuitively, which is a lot of points in my book, because that's the other problem with using something like, you're like, oh, well, I'll use Trello because they'll know how to use it. But then it's like, I don't know, they just spew everything into a card and then they don't do anything with it anyway. And so this has a little bit more organization, which I think helps them stay inside the lines. But it's also pretty intuitive and simple. So I'm still seeking the perfect thing, but this is pretty good. So that's my serious pick. So Smartsheet. And then my fun pick is I have been recently having a absolute blast playing Valorant, which is a first-person shooter if you're not familiar with it. It's a game that's fairly popular. And so it's a lot of fun. If you are somebody that back in the day maybe played like Counter-Strike or something like that, it feels a lot like that. But I did play Overwatch for a while with people, and while that was fun, Overwatch became less fun over time. And anyway, some of my friends got me into this, and it's a blast. So there you go. Those are my two picks.
Cool. Valentino, what are your picks?
So my coworker Wes, he created this awesome article on how we do co-ops at Doximity to kind of spark innovation. We do it every once in a while. I'd recommend checking it out. We basically build like small teams that work together across teams, across practices. And it's kind of like a little competition to see what we can build and make. So kind of fun. See if it works for you. My other two are Ruby related. One is this great evolution of Ruby from 2.0 all the way up to the recent Ruby. It's a great breakdown of all the changes that have been made over time. Really cool to see the evolution of that. And kind of piggybacking off that is the original Try Ruby from Y, the Lucky Stiff, has been integrated officially into the RubyLang website. It's gotten a little facelift, and it's really cool looking. I recommend checking that out as well. Really cool stuff to see.
Nice. Luke, what are your picks?
Well, I'm going to pick one of Maximo's pages to start off with, but not for the reason you think. Maximo's got a post on his site called Debugging Ruby Libraries. But what stood out to me is it's got an animated SVG thing. And I don't know how you've done it, but it's if you zoom in, the text is absolutely sharp, and it's one of the coolest things I've ever seen. So however you did that is fantastic. My second very boring pick is a kind of book I found online called Linux insides. I've been interviewing a lot of embedded C developers this week, and I thought I'd better brush up. So if you want to kind of get it really into the way Linux works, then you can read that. Great. And my last pick, which is easily the most interesting, is a book by Boccaccio, who was a 14th century Italian author. And what this is, and you read the English translation, right, is it's a series of stories within stories, like Arabian Nights, right, or Canterbury Tales, where people are telling each other stories inside the book. And this is pretty naughty stuff. This is pretty subversive for, 1353. It was written just after a major pandemic, like, the Black Death. So it's kind of got a certain resonance to these times. And a lot of the things you read in this book have been stolen and reused in famous Shakespeare plays. So you're reading it, you're like, do you know what? I kind of recognize that. Anyway, it's a weird pick, but I've been really enjoying the Decameron by Boccaccio. Loads of English translations available, translated into every language under the sun.
Cool. I'm going to jump in here with some picks. So lately I've been working on a couple of things. I guess I should do a board game pick first, right? So I've picked this before. I was playing it with some friends of mine. You know what? Scratch that. I'm going to pick a different game. And I had some friends over. There's a long story to why they were here, but we decided to play a game before they left. And so I pulled out a game that we've had for a while called Orbis. And it was funny because my one friend compared it to Splendor. If you've played Splendor, I'll pick Splendor next week and talk about it. But so Orbis, you wind up kind of building an engine. It's kind of the same as Splendor in that way. But what you do is you are building a universe, and your universe is basically a pyramid of tiles and they're hexagonal tiles, but you're building a universe of tiles that's a pyramid shape with 5 at the base, right, and 1 at the top. And what you do is you essentially buy the tiles that go into your universe, and when you buy tiles, it populates other tiles in the space you can buy them from, and populates them with worshipers. And so you collect worshipers and then you spend worshipers to get more tiles. But you can only build a tile above a tile of the same color, right? So, and directly above, right? So if you have a blue and a yellow tile together, you can put a blue or a yellow tile kind of where the two meet above it. But if you put a blue tile in, then unless you have yellow tiles in that next row, the row above it can't have yellow tiles in it. Unless you sacrifice a spot and put a wilderness in, which is a wild, but you lose points for having wilderness tiles. So that's kind of the way it works. And you get points for building different kinds of tiles. So you get points for having the most temples, or you get points for having fields with the right kinds of things surrounding it, or you get points for sacrificing worshipers when you buy a particular kind of tile. So that kind of a thing. It activates the tile and you get points. You can also bring in a deity, and the deities have different effects at the end of the game on how you score your universe. And so anyway, it's really a ton of fun. It's actually a rather short game. It's a 45-minute game, I guess. And anyway, so I really liked it. On Board Game Geek, it has a weight of 2.09, and it says ages 10 and up can play it. I could see that. I think my 10-year-old, as an adult, I'm a more sophisticated game player, and so I would probably win on a regular basis, but he could grasp the game and play it. I have a 10-year-old. So anyway, I really like it. It plays 2 to 4 players, right? So when I get my big game group together, we don't play it because too many people, but anyway, it's pretty fun. So I'm going to pick Orbis, and yeah, then I will go ahead and start shouting out some of the other stuff. So one thing that I'm going to be putting together in August is meetups. And for those that have kind of been following along with the whole Top End Devs thing, you've been able to sign up for a coaching call with me at topenddevs.com/coaching. And as I've talked to more and more and more people, and I'm telling them, hey, look, here are a couple of things you can do right off the bat to take your career to the next level. One of them is going to meetups. And I've been talking to people, and they can't find a meetup near them, right? And this didn't used to be a problem, but COVID shut down a whole bunch of them. And a lot of those just haven't come back, is kind of where we're at. And so I'm going to start doing meetups. You can go to topenddevs.com/meetups. I'm going to be adding them to the calendar today. If you're hiring and you want to do a shout out during the meetup, go to topenddevs.com/sponsor, because that's what I've been telling people to do. They're how do I hire great Ruby devs? And it's like, well, look, you got to get them where they're showing up at, and you've got to catch them when they're not happy where they are. So anyway, it just seems like kind of the best of both worlds, because those are the two groups of people I'm talking to. So topenddevs.com/meetups. And then I'm using a system called AirMeet. That's AIRMEET. I've mentioned it on the show before. We're going to have that together. We're going to have tables where you can come and sit and chat with each other and, all that good stuff. And I am looking for presenters as well. So if you have something you want to show off, I'm expecting you'll screen share and write code or have slides if you're talking about something that isn't code, or maybe both. So anyway, we're going to be putting all that together, and we're going to be starting that up in August. And then one other announcement I do need to make is that Rails Remote Conf, I've had to postpone it just because getting all the pieces together for that has taken me a little more time than I wanted, but we're going to do it in September. So I'm talking to DHH. We're going to get that rescheduled. He was going to come do a Q&A on that. I'm assuming that it probably won't be a problem for him to do it in September. But yeah, anyway, so keep an eye out for that. We're doing a JavaScript one in September as well. So if you want to kind of bone up on what's going on in the JavaScript world, definitely check that out. And then finally, the last thing is I'm looking for hosts for a Node-focused podcast. I don't know that those people necessarily listen to this show, but I thought I'd put it out there. So if you're interested, just email me, chuck@topenddevs.com. And yeah, I know a lot of that's kind of self-serving, but I'm hoping that it's self-serving in a way that it's, hey, this is the thing I'm putting together that will help you out, right? So anyway, we'll have links to all that stuff in the show notes. Maximo, do you have some picks?
Yeah, to answer what Luke asked about the SVGs, the animated SVGs, it's a combination of 3 tools. The most important one being ASCII Cinema, which is something that you have probably seen in the wild. You can record your terminal session and it will just play it back. It will record it as characters. So someone created a way to export those ASCII Cinema sessions into SVG. And then I'm using a tool by Jake Warren, which will just handle some of the rendering issues, VSync. And as a result, you get this super smooth terminal session that can be played back as an SVG with full color. So it's just beautiful. The first time I saw that, I think it was in Jake Wharton's blog. So that's where I got the technique and all these other libraries. So props to him. And then my pick of this week is Inertia Rails, which is Inertia.js is the library that I mentioned, which allows you to use your front-end views where your components are pages and receive props, which is the data that the backend provided. And Inertia Rails is the Rails version of that, maintained by the folks at Belawatt. And it does the job wonderfully. It works really, really well. And I'm really happy using it. I think it's a very productive way to have like a full front end, like fully JavaScript front end with a Rails backend.
Very cool. All right. Well, we'll go ahead and wrap up here. Thanks for coming. This was a ton of fun and very interesting.
Thank you for inviting.
All right, folks. Well, until next time, Max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.